These are the notes that you need to watch for Monday night. I'll be giving 5 points just for you having completed them. I also say some stuff you're going to want to listen to along the way, so I wouldn't speed me up. I say a few very important things that you'll say, you never told us that. We're having a test on this on blah, 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 blah. And I'll say, yes, I did. I said it in the notes you were supposed to listen to. So I'm very tricky that way. So in all the classes, we wrapped it up. We got to about right here. So we're just going to finish up the notes, and then I'm also going to do number 5 on the worksheet with you. So we're going to use the formal definition of the derivative, also known as the limit process, for finding the derivative of our function, which we already did up here, but we did again that alternative form, which is for the derivative at a point. So our function is 2 over x, so let me write that down. F of x equals 2 over x at x equals 3. And we figured out both on our calculator and from the alternative form that our derivative, also our slope of our tangent line, is -2/9. So let's do it. The long range, remember the process that we're doing right now will give us the derivative at any x value. This up here was just at 3. So my derivative at any x value will be the limit as h approaches 0 of f of x plus h. So I will remove this and put in an x plus h minus f of x. Well, that's just the function itself, all over h. Remember, for the complex fractions, we do that crisscross, multiply across, and collapse as a product. So I say 2 times x minus, or subtraction is my link, 2 times x plus h. So I'm going to call it 2x. I think I'm just going to distribute it in if you don't mind. So 2 minus 2x minus 2h all over, so that's my criss, minus my cross, all over multiply across x times x plus h, and then it's all over h, which we'd multiply by the reciprocal and do 1 over h, which just collapses it on the bottom. Remember, all non-h terms should cancel, and they did. Then I can cancel out my h, and it leaves me with the limit as h approaches 0 of -2 over x times x plus h. Now I plug the 0 in for the h, and it gives me -2 over x times x plus 0, or just x times x, or x squared. This right here is a function of x. It gives me the derivative anywhere along the function. And remember, the function actually is the parent function with a stretch of 2 for our hyperbola parent. So I'm actually looking for the slope of the tangent line at 3. I already figured out in part A and on the calculator in class that that was -2/9, which looks about right from this graph. This should look a little bit more asymptotic here, horizontally. So sorry, let me kind of get that going. Anyway, let's see if this jives. According to my calculations, f prime at 3 can be determined by plugging 3 in for x in my function for the derivative. And lo and behold, I get that -2/9. So the question is, which process is better? To be honest, in a couple days, you're not going to use either one. We're going to have ways that really shortened it up. And I already talked about the product rule with some of you. I think every class maybe I did. But remember, I said that the power rule, I mean. This function is really 2x to the negative first. And I said the shortcut we're going to learn for powers, or polynomials, is that we can bring that out front. So I'd have -1 times 2, and then I drop the exponent 1. Well, -1 minus 1 is -2. You'll notice that my derivative, using what we're going to call the power rule, which I wasn't going to introduce until tomorrow, but some of you physics kids were already told, so I might as well get it over with right now. Notice I arrived at that same function that this long process gave me. And again, it gives me the derivative anywhere. This process up here is specifically at a point. It's called the alternative form, which there have been years where I haven't even taught the alternative form, but I do like them both. So we'll start this one, but not finished. So this says find the derivative using the limit process. You'll notice I'm not saying at a specific point. So what that means for this one is that my derivative will be found by taking the limit, not as x approaches like 4, but this is where that change approaches 0 of f of x plus h minus f of x all over h. So I'll start this one. I don't know if I'll finish it. I'm mainly starting this one for the expansion of x cubed. So my derivative, a function that's going to give me the slope of the tangent line anywhere on the curve, is going to be equal to the limit as h approaches 0 of f of x plus h. So let's go put in that x plus h for all the x's. Here's f of x plus h minus f of x, so minus f of x all over h. Again, if I do this correctly, all non-h terms should cancel. I need to expand this. Make sure you don't call it x cubed plus h cubed. It's x plus h times x plus h, FOILed, times x plus h. Or maybe you remember from Algebra 2, I know Mr. Michener teaches it, the binomial expansion theorem. In which case that'd be awesome. It comes from Pascal's triangle where the coefficients you can grab. I think if you had to, you would just FOIL these and then multiply by x plus h. I'm going to use the expansion theorem. You don't need to have this memorized. Just, be able to multiply it out if you had to. But I do x cubed, h to the 0, plus 3x squared h to the first, plus 3x h squared. The power on one of them goes up while the other one goes down, and I get the coefficients from Pascal's triangle because I just have it memorized. But this is what you would get if you manually just multiplied all this out, which is what most of you would do anyway. So there's my x plus h cubed, and then I'll have plus the 2x plus the 2h minus 3, that's all this. And then distributing my negative in here, I'd have a minus x cubed, boom, boom, a non-h term canceled, a minus 2x, boom, boom, a non-h term canceled, and a plus 3, gone, gone. So notice everything left has h in it. I'd factor it out, I'd cancel, etc. Now, you can finish that off if you want. We've done enough of them. I'm going to end up with 3x squared plus 2. You might say, how'd she do that so fast? I used the power rule. I brought it out front, knocked the power down 1. I brought the 1 out front. 1 times 2 is 2. I knocked the power down 1 to 0, and we talked in class about constants always going to 0 and y. So this function will give me the derivative anywhere along that original cubic function. So if I wanted to know, hey, what's the slope of the tangent line when x is 0? It'd be 3 times 0 squared plus 2. It'd just be 2. All right? So it says find the slope when x is 1. Well, 3 times 1 squared, right? And what was it? 3x squared plus 2. It would be 5. So I'd like you to verify that on your calculator using Math 8. Get used to that. We've talked about it in class. This one's really similar to the one I'm going to do, example number 5, in your notes. So, on your homework assignment, problem number 5. So I'm just going to leave that one undone for now. It says, remember your goal in this process. We want to be able to factor that h out and get it to cancel with h on the bottom. Be very careful with your signs, and always remember factoring's awesome and your algebra needs to be great. So this right here, I wish I'd gotten this far in class because I would have liked to see who could have answered this question. By the way, we're not in the book yet. We will be, but I'm still staying out of the book. I like to see who can answer this question because it means you really get it. And so maybe some of you might, if the function is constant, like f of x equals 3, also known as y equals 3, what do we think the derivative is going to be? Well, no matter what x is, my derivative is going to be 0 no matter what. Graphically, maybe it's because you know that the original function The original curve was actually not a curve at all. It was a horizontal line through 3. And the slope of the tangent line at any point would just be the slope of the line, which is 0 right there. So that's kind of nice. But if I use the formal definition, remember my f of x plus h would also have been 3, because no matter what you input into f, a 3 comes out. So when I do the top of that difference quotient, I'd have f of x plus h, which is 3, minus f of x, which is also 3. So I'd get a 0 in my numerator, and it would jive. So the derivative of any constant, no matter what it is, is always equal to 0. So we don't need to go through the long process at all. Same with for a line. If my function, let's call it y this time. If my function is y equals 1/2 x plus 2, and if I were to ask you, well, what's the slope of the tangent line anywhere on, well, that line? What you would do is you say, well, I'm up at 2, I go up 1 over 2, up 1 over 2, and if I said, I'm just going to plop you on here over at pi. And if I say, what's the slope there? Well, it's the slope of the tangent line is the slope of the line itself. So my derivative, remember I'm trying to change notation on you, will be equal to 1/2 everywhere. So the derivative of any linear function, the slope of its tangent lines, it's always just the slope of the line. Now, if you use the limit process that we were practicing for this, you'll get 1/2, but don't. I mean, you would never, these two can just be easily done. If I said, hey, what's the derivative of y equals 5x minus 2? You go, that's a line. The slope's 5 everywhere, so the slope of the tangent lines will be 5. That'll help you with number 7 and 8 on your homework. Speaking of which, we are going to go now oh, by the way, this is one of those things that I said you're going to want to have listened to the notes. There's extra credit, and it's linked in Schoology. I would want it by Wednesday, or this is a website where you can go and click. It's called Visual Calculus, and there's 7 of these definition of the derivative problems, and if you click, you also get the solutions done for you too. So you could just do those on a sheet of paper by Wednesday, and again, that's for extra credit. The other thing that I was going to tell you is that on Wednesday I'm going to give you actually a homework test, just because I want to make sure you're not copying that algebra, because I get very algebra intense on the homework. On Wednesday, I'm going to give you one of the homework problems from 1 through 4. Okay, so one of the 1 through 4s on today's worksheet will be for test points on Wednesday. And then I'm also going to give you one problem from the assignment I give on Tuesday. So just one problem off the 2.1b worksheet, 2.1a. Remember, the worksheet is in Schoology. I'm going to go bring it up right now. 1 through 4, make sure if you're looking at that key, you can recreate it, because I'm going to give you 5 points for this and 2 points for this, for 7 test points on Wednesday. It will be timed. So if you think, I'm just going to wing it and hope I can get her done and figure it out, you won't have enough time. So make sure you've got that process down. We are going to go right now and take care of number 5 on your worksheet. So in Schoology, your worksheet's loaded, and I want to fill in this for you. So take out a sheet of paper and label it 2.1a. And I'd like you to pause this video and draw this box in. And we're going to fill in the 2 top parts together. And then we'll also together go do number 5. So hopefully you paused, got this sketched out. I'll be checking that this is done tomorrow as well. So I'm going to check notes and that you've started the assignment for a 5-point homework assignment. So Tuesday. Just make 100% sure you know what's going to happen. I'm going to walk around the room, and I'm going to say, have your notes out for that page I just did, the video notes. And I'm also going to say, have your homework sheet out where you've started the homework. You don't have to finish it till Wednesday, but you should have this top chart filled in, and you should have number 5 completely done. So let's complete this table. Definition of the derivative. This model right here is called the formal definition of the derivative. It gives a function. The result is f prime of x, which means the derivative of f at x, which is f prime of x, which is, the result is f prime of x, let's write it properly, which is a function of x. This one right here, the alternative form, is at a specific place. So if a is 2, this is the derivative at 2, which, by the way, this will give you as well. We just showed it if you plug 2 in to your derivative function. So this one, the result is f prime at a, which is the derivative of f at a. So again, this one, anywhere on the curve. If I plug in a 1, I'll get the slope there. If I plug in a 2, I'll get the slope there. If I plug in a 3, I'll get the slope there. This one is at a specific spot where they say, what's the derivative at 4? And you plug 4, you go through this process, and maybe you get it to half. Your answer is a number for the second part. So it says, separate sheet of paper for each function listed below. I'm going to write down. We need to find f prime using the definition. What does my answer represent? Calculate f prime of 2 using this. What's my answer represent? Now use the alternative form. That's this bottom one. And then confirm on your calculator. So we'll go take a look at number 5. So on a blank sheet of paper, you should have already done the one up on top, filling in the chart. And now we are going to go take care of number 5. Let's go do it here. All right. So number 5, I already forgot what it was. Now I got to go back. Oh, dang it. Number 5 is 1 over x squared, and we're dealing with this at 2. So 1 over x squared. F of x equals 1 over x squared. For part A, let's blow this up a little bigger. For part A, I'm going to take the limit. Hopefully, right? And as h approaches 0, because I'm supposed to use the formal definition, and again, this is going to give me f prime of x, a function of x. Limit as h approaches 0 of f of x plus h. So I put x plus h into the function for x, minus f of x, the function itself, all over h. And again, if I put h in right now, 0 in for h right now, I'll get 0 over 0. So again, my goal is to find that h in the top as a loner so I can cancel it off. This is a complex fraction. So this is the kind where I technically get a common denominator, but it's easiest just to go criss. Minus cross. All over. I'm going to erase that. Multiply across. And multiply by the x squared. So that's just crisscross, multiply across, collapses as a product because we really multiply by 1 over h. Now my goal is to get everything without an h in it to cancel. So I can factor the h out so that I can also cancel it. So I'm going to need to expand this guy. Keep in mind I'll have a subtraction in front of its expansion. Foiling would give us firsts. Outside xh, inside xh, and lasts. All over x plus h squared. Remember in our limits chapter I said do not multiply that bottom out because you want things to cancel and you want to see them cancel. So you don't deal with the bottom. On the top, my non-h terms should cancel, or I've done it wrong. They do. X squared minus x squared is gone. And I'll be taking the limit as h approaches 0 of negative 2xh plus h squared, oops, sorry, sign error there, minus, I should actually have distributed this all in and rewritten it, but I'm not feeling it right now. So x squared, and then this is all over the quantity x plus h squared times x squared times h. I factor the h out on the top. What does it give me? An h times a negative 2x minus an h all over, again just factoring that guy out. A lot of writing. Meanwhile, I could have just used the power rule, right? But we're pretending we don't know that. AP Physics kind of spoiled it for us, so I had to spoil it early. That's okay. It's a good thing, right? So what am I doing? I'm canceling. Gone. Gone. Now I'll put 0 in for h. So on the top, I'll have a negative 2x. And on the bottom, you might say, LaRude, you said we can't drop the limit until after we've plugged in. That's what I'm doing. I have two variables here. H is the one that's in control of the limit right now, or the limit process. So you can drop it once you put in a 0 for h, which is what I'm doing. When I put in a 0 here, I'll have x plus 0 squared, which will just be x squared, times another x squared, this guy. So I have x to the 4th. So when I'm all done, my derivative, f prime of x, is equal to negative 2 over x cubed. And then the other part of the question said, what does this represent? This gives the, and I'll let you write it while I say it, just in case people are just watching and not listening. This gives the derivative, comma, slope of the tangent line. So this gives the derivative, comma, the slope of the tangent line, comma, at any x value along the curve. Actually, it's except at x equals 0, because you'll notice there's an issue if I put in a 0. But remember, the original function had us an issue too at 0. There's an asymptote there. So that's a discussion for Tuesday about how continuity is necessary to actually calculate derivatives. And this function's not continuous at 0, therefore its derivative is not calculable at 0 either. All right, then it said for part B to use that to find f prime of 2. What would the slope be at 2? It would be negative 2 over 2 cubed. It'd be negative 1/4. Part C. And then I think this one also said, what does this mean? This means the slope at x equals 2 is negative 1/4. It's going downhill quite gradually there. All right, for part C, we're supposed to actually get this same answer using the alternative form. Remember the power of this, guys, I can do it anywhere. Now I'm going to use that alternative form. I'm going to be taking a limit as x approaches specifically 2 of f of x minus f of a, f of 2, all over x minus a, or x minus 2. This will give me the derivative specifically at 2. If I do it right, I better get negative 1/4. So let's crank it on out. This will be the limit as x approaches 2 of f of x. It was 2 over x squared. Wasn't it? 2 over x squared? I gotta remember. I wrote it way up here. 1 over x squared. Good thing I went and looked. Something felt weird about it. All right, of 1 over x squared minus f of 2. Well, if f of x is equal to 1 over x squared, f of 2 is going to equal 1 over 2 squared, or 1 over 4, all over x minus 2. Cleaning up the complex fraction issue on the top. Again, if I put in a 2 right now, I have 0 over 0. I've got 4 minus x squared, all over 4x squared, multiply across, and then collapse as a product. I'm feeling good about this because that top has my issue hiding in it. So I've got my limit as x approaches 2 of 2 minus x times 2 plus x, all over 4x squared times x minus 2. Now I cancel. 2 minus x and x minus 2 are opposites. They cancel to give me a negative 1. Now I'll plug the 2 in. And on the top, I'll have 2 plus 2, which is 4. Boom. But there's a negative out front. On the bottom, I'll have 4 times 2 squared. 4 times 4, which is 16. What a shocker. Right? This is called the alternative form of the derivative of a function at a point. Negative 1/4. The directions also said to explain what that means. Well, it means exactly what it meant in part B, because it's the same question done a different way. The power is actually in part A, where you get a function. So that I want to know what happens right here when x is 1,000,001. I can just plug it into my function. All right, part D said use your calculator to confirm your answer. So you're going to hit your Math 9 button, and I want you to write it like this too. I don't just want you to put an answer. On your Math 9, you'd fill that box in with an x. My function was 1 over x squared. It was actually the volcano graph. Whoop, whoop, right? And I just found that when x is 2 on the volcano graph right here, at 2, the slope of the tangent line there is negative 1/4. It looks pretty good on my graph, doesn't it? At x equals 2, hit enter, and it should say negative 0.25. And then there again, we talked about how there might be, it might go 0, 0, 0, 0, and then kind of crap out at the end. And we talked about why that is in class. So this is how. So you've got 4 more to do on your own, 1 through 4. And then the 7 and 8 you should just do in a less than 10 seconds. So tomorrow, again, I'm going to be checking notes and that you've done this problem for a 5-point homework assignment. The entire assignment's due Wednesday. There's a key posted. You might want to take care of it all while it's in your head, but I'm not going to collect it till Wednesday, at which time after I collect it, I'm giving a homework test where I'll pick 1 out of 1 through 4. Have a good one.